Okay? Take the bottom, set it equal to 0. Now it's a quadratic. There are different ways that you guys will handle the quadratic. Maybe you factor it. I don't know. So that quadratic factors in, it's a difference of squares, so x minus 1, x plus 1. So when I set each one equal to 0, I get 1 and negative 1. Those are possible restrictions on the domain. Is there any factoring to be done up top that might match the factoring I did on the bottom? No, this time, no. So go to 1. Go to negative 1. And we put in the 2 vertical asymptotes. What degree do I have on top?
1.
First degree. What do you have on the bottom?
Second.
What happens when it's small degree divided by big degree? Goes to 0. Eventually it'll go to 0. What happens when you plug in x is 0? I guess I've been doing that in orange. What happens when you plug in x is 0? 0 on top divided by negative 1, which is 0. So I have, again, x and y intercept at 0, 0. So somebody that has graphed it, anybody graphed it yet? What are you seeing?
Just 3 lines.
Where?
One on the left. This little thing.
Lower left or upper
Lower
left? Right. So you're seeing lower left.
Oh, you still want me to tell
They're
you?
weird.
And there's something in the middle.
Is it a tangent or tangent, right? So that means it's coming up and going up to the right. That's tangent. So it must be cotangent.
Yeah.
It's kind of an S-shaped curve in the opposite direction of our x cubed. That's fine. And then top right corner. That makes your life a little bit easier than what it used to be for us, because I would suggest, in a group, everybody graphs it so everybody has the same picture, and then you go through and find your vertical, horizontal asymptotes. What I used to do is we'd have to go, okay, well, I can't use negative 1, so we'd pick numbers just a little bit bigger than or smaller than negative 1, so like negative 1.001. Plug it in and see if it explodes in the upper or downward direction. Upward or downward, and then you go to the next one and you say, does it go upward or downward, and you would slowly plot them out. You guys have the graphic calculator, so you just type it in and graph it. X squared over x plus 1. X plus 1 is my denominator. I'm setting that equal to 0. I'm getting negative 1 for a restricted value, a critical value. Can I do any factoring on top that might possibly give me an x plus 1 factor? No. So negative 1 is the only restriction on the domain, so let's go ahead and graph that. What kind of degree do you have on top? Second. First. What happens when it's big over small? It's a slant asymptote, which means you go right into polynomial division. So we're taking x squared and dividing by x plus 1. So put x squared in the house. X plus 1 sits on the outside. I want exactly x squared under here. So what times x gives me x squared? X. X times x is x squared. Remember, you take whatever number you put on top times everything. You distribute to everything on the left here. So x times 1 is x. Put that in parentheses and subtract. So the point of doing polynomial division is that x squared minus x squared is 0. And I don't need to write it in. Now we have like terms. What's 0x minus x? Negative 1x. Should I stop or do I keep going? These are equal degrees still. You keep going until they're smaller degrees on the bottom. So what do I have to put up top so that times x I get negative 1x? Negative 1 times x is negative x. Put it in parentheses and subtract. What's negative x minus negative x?
Why didn't you use the 1?
Oh, I'm sorry, I forgot my one. I was so excited to finish that.
Me too.
Alright, negative 1 times 1 gives me negative 1, thank you. Now when you subtract, negative x times negative x minus negative x is 0. And 0 minus negative 1 leaves me with the remainder of 1. But the thing about polynomial long division for finding the slant asymptote, let's go to this color. It's right there. So when you stop, what's up top is your slant asymptote. So we're going to graph x minus 1. So that would be down 1 for its intercept. A slope of 1 means go up 1 over 1, up 1 over 1. So it's kind of lining up there, and I will label it y equals x minus 1. What happens when I plug in 0 for my x? When x equals 0, what does y equal? 0 over 1, which is 0 again. So it kind of looks like my graph is going to be right here. And I assume in this corner. Is that right? X squared divided by, was it x plus 1?
Yes.
So when you graph it, you see these two things on there, and you might be able to visualize, okay, what's happening there. So to check that somebody in your group has done the correct slant asymptote polynomial long division, go back in there and just put that in, and we had x minus 1. Just to make sure it fits. Let's say somebody, when you did your subtraction, let's say they did, some sort of sign error and they ended up with x plus 1. You don't know how to do polynomial long division, so your friend did it and they made a simple error. The slant asymptote cut through the graph, right? So that's pretty obvious that something's wrong. It's the graph didn't. This one looks okay. You might go, oh, that's fine. But when you look at the top here, okay? So you can check your slant asymptote. Determine the horizontal and vertical asymptotes and then graph it. What are we going to do on the bottom?
Set equal to 0. X plus 1 and x minus 1.
Let's do it this way. Set the bottom equal to 0. Both the negative and the positive way, right? So this one I can just go x is 1. Over here, I should really distribute the negative sign. Then divide by negative 1 at the end. Right? In this case, it turns out that there really is only one value. Right? The only value when you look here is the only way you're going to get 0 on the bottom is if it's a 1 being plugged in. But its absolute value, always plug it in twice. I'm gonna stop there at that problem, you guys can finish it, but there's one like that on your homework. Okay, let's try this one. How does x squared minus 9x plus 20 equal 0? How's that factor? X minus 5, x minus 4. And so what's happening is I have 5 and 4 as my two critical values, right? Is there any factoring that you could do up top?
Yeah.
What? What'd you say? Pull the 2 out front, what happens? You're left with x minus 4. So you kind of have the feeling that you want to do that, right? What does that tell you when the factor appears on the top and the bottom?
There's a hole.
That there's a hole in that one. So the 5 and 4 are considered restrictions. 5, however, is the vertical asymptote. So go out to 5. Where's my horizontal asymptote? What's my degree on top? Degree on the bottom. What happens when it's the small degree on top, big degree on the bottom? Goes to 0. Anybody graph it yet? No? So, on top, make sure you put it in parentheses. Is it 2x plus 8?
Minus 8.
Minus. Divided by x squared minus 9x plus 20. So when you look at this graph, what it looks like is there's only one vertical asymptote, correct?
Yeah.
So you can go back to the graph, and you can see that it's here doing something like that, and it's up here doing something like that. That's what it looks like on the graph. But what we need to understand is that well, let's get this in here. What happens when you plug in 0? When x equals 0? Y equals negative 8 divided by 20, which would be divide them both by 4, negative 2/5. So that's 0, negative 2/5, or negative 0.4, right? But what are we missing on our graph? What do we do at 4? When x is 4, what should we do? We should go back in there at 4, which would be about right there, and literally draw the hole in the graph. So if you go back to the graph, and this, I'm going to switch my window, you can just watch up here. I'm going to go from 3 to 6. So I went 3 to 5 this time. Yeah,
Whoa.
but when you graph it, I'm just putting it in there. According to my graph, my green line should have been more up there. You know, but what I will be looking for on the graph is that you recognize, even though there are 2 restrictions on the domain, one of them is vertical asymptote, one of them is a hole. And then you can draw it in.